And I'll get started as soon as the attendance is. And let's try to solve this. Okay, so I added some more letters on the corners of the triangles, and that shouldn't throw you off. Okay, it's just a bit more information here. So determine the measure of the following angles. So remember that, recall yesterday we started to talk about inverse functions. And what that means is that, right, if you think of sine, cosine, and tan, those are trig functions, and each of them has their own inverse. Okay, angles, right? These ones will give you angles if you use the inverse. Okay. So if you look at the first one, they're asking for this side here. So if you look through the steps that I gave you yesterday, which should be on your study sheet, this is your reference angle. So you label the two that are known. If there are more than two given, then you'll label only two of your choice. So this would be the opposite side. This would be the hypotenuse. O and H means that you're going to use sine, right? So sine of, we're going to use the letter that's next to that, capital A, and in the order 17.9 over 24.8. We turn that into a decimal, right? And I'm kind of running out of space there. And we want to make sure we use 4 decimals at least. 0.7218. So to get A, we will have to go sine inverse because we started with sine 0.7218. And I hope you did the work that I assigned yesterday. And that is 46.20 degrees. That's how you find angles. Okay? Should write that down. Next, we have this triangle here, triangle XYZ. Put a line here, which I asked you to copy already. You are now situated here in this corner because that's the angle in question. You travel out, that's the opposite side. This would be the hypotenuse here, but I don't care about it, so I'll label the adjacent. So it's O and A. That'd be TOA, right? TOA. So I have to use tan of Z is equal to opposite over adjacent. Let's come up with the answer to that. You just divide them. And that's 0.1953. So Z would be tan inverse of 0.1953. So remember, you go shift tan or second tan 1953 and you get 11.05 degrees. And there it is. One more. So write it down. Write C down here. Do you have a calculator or decent? Yeah. Okay. Okay, so here we're situated there. Label opposite. Oh, I won't label that one because I don't care about it. That would be the opposite. Hypotenuse adjacent. AH, you're thinking of ka, right? So cosine of what? It needs to have an angle attached to it, be it a number or a letter. And that's adjacent over hypotenuse. We get 0.9156. Angle E is cosine inverse of 0.9156. You go shift cos, and that's 23.71 degrees if you round it. So there you have it. We went through sine, cosine, and tan, always having to take the inverse of that. So basically 3 lines, right? You set up, you come up with a decimal. This would be 1 line. Another line where you show that you're taking the inverse. That's very important. And then 1 line with your answer rounded to 2 decimals. Make sure you round to 4 decimals here before you make it to the end. Okay. I got, oh, okay, somebody's saying maybe I typed it in wrong. Hold on. Yeah, 51, right? 51, 58. My bad. And so that will also change my final answer. That's 58.95 degrees. Thank you. That's better, right? Thank you, guys. Benedict, Isabel, thank you. Please correct that. That was my mistake. So that would have probably cost you half a mark if that happens. So be careful with that. Okay, so we go on to the next part. Identify the angle of elevation and depression. So I want you to put an arrow pointing towards the angle of elevation. So you can just go elevation and make an arrow go where the angle of elevation is supposed to go, and depression, and make an arrow go towards the angle of depression. You can actually just use these two and just use an arrow from that and then point it in the right direction. Use a pencil unless you're very quite confident. So this is basically just a rectangle with a diagonal across. And so in this particular situation, the angle of elevation is between the horizontal and the line of sight going upward. So this angle right here would be considered elevation. That would be the angle of elevation. The angle of depression is between the horizontal and the line going down. So this over here would be depression. So you need to know that there's a relationship between them, but you need to know exactly where they are in order for you to be successful, especially when you're doing a word problem, right? Yes, Francis, go ahead. Okay. Yeah, that's fine. Thanks for letting me know. So there it is. Hopefully you have that down. I would add this to my study sheet, to be honest, right? Because then you know exactly, right? Like if you're looking at an angle depression, this is what your triangle looks like. If you're talking about angle of elevation, it should look like this, right? Where you have a horizontal, the ground, right? And the line of sight going up. So there it is. So they're basically stacked. So backside for me, you just continue. Let's call this understanding angle of elevation depression, okay? So it's just continuing from what we just did. Okay, so this might require you to think outside the box a little bit, okay? If this is a right triangle, right? This we know is 90. This is 30. What would this angle be over here, up here? What would it measure? What do we know? All three angles always add up to 180 degrees, right? So if this is the case, then this angle right there would be 180 degrees minus the 90, right? This is the 90, minus the 30, and that would be 60, right? Essentially what you want is that the two remaining angles add up to 90, because then that 90 plus the 90 you already have is 180. So this is 60 degrees here, okay? Now, let's add, I'm using a different color because then you can tell that I added that afterwards, right? I'm going to use a ruler, but I'm just going to say, hey, if I were to do this here, if I were to go to the top corner here and extend that line, and I'm going to make it dashed like that, okay? If I were to extend that, what would this angle right here be? Any guesses? The vertical, this is a vertical line, right? And the horizontal, they make a 90 here, okay? So if you're cutting, right, if you're cutting away 60 degrees here, then this would have to be 30, right? Because if you have a 90 here and you're telling me that this portion is 60, then this has to be 90 minus 60, which is 30. This is the angle of depression. We call that depression. And this over here is elevation, right? Based on the name we give them. And what do you notice about the angle? The angles, they're both the same. Okay, so in reality, it doesn't matter how you draw it, is that these two will be the same if you draw it like this as a rectangle with a diagonal across. The problem is a lot of students put this 30 when they think of angle of depression, they'll put it in here, and that is wrong. The red one is not the angle of depression, it's this one up here. Okay. So yeah, I need you to understand that if you were to flip, this triangle, you rotate it, you would end up with, right, this 30 would end up right here. And so they are the same, but only when they're drawn like this, when you draw it like that, okay? So if you want to, you can also have a dashed line here. So there, you basically have a copy of a triangle. One is flipped upside down and one is right side up, okay? So I need you to understand that. Maybe I will add here note here. Two angles adding up to 90 are called complementary. Sorry, this is supposed to be an E, complementary angles. Okay, so you need to understand that. Okay. I wanted to jump into word problems. So before I do that, so don't write this down yet. I want to review. I just need you to make sure you understand how to solve for sides. I just don't want to solve for the missing side. Before we do word problems, we'll do one if not two, maybe I'll do two. So I'll call this A, and this will be B. So maybe write them both down side by side. Solve for the missing side. And I really hope that you did the homework that I assigned yesterday, that worksheet with the inverse, which also had the answer key at the back, right? To practice, like, how do you find angles? And so here we go. Where's your reference angle? Well, it's the one that is given to you, so it's this one. Label two sides that are involved. This will be the opposite, hypotenuse. Don't care about it, right? The adjacent. So this would be a so scenario, right? So sine. Sine of, in this case, you know what the angle is, 29 degrees, is equal to opposite over hypotenuse. We put the 1 here. This is a cross multiplying and dividing. No inverse here. It's 1,021 times 1 divided by sine of 29. And that is 2,105.98 meters. So that's what we've been doing up until now, right? Solving for the sides. So have that written down. Next, B, have a triangle like this. You are located in this corner because the angle is there, right? So no inverse here if you know what the angle is. You take it, it's opposite. Hypotenuse, don't know, don't care about it. It's the adjacent. So O and A, that's TOA, right? Tan. So tan of 17.5 degrees is equal to opposite over adjacent. But the 1 here, not really needed, right? It's just that times that divided by 1, which is irrelevant. So x is going to be 245 times tan of 17.5. 77.25. And we are in millimeters. So make sure you know that when you're finding sides, it will have like a dimension for length. And if it's angle, if you're using inverse, it will always be a degree at the top. Okay. And now, I would like you to find a worksheet that I had given to you. If you came through my class, this is what we're going to use for work problems. So try to find this TRIG work problem worksheet. See if you have it. If not, give me 1 second. I'll see if I can post it. Do a few so that you can do the rest, okay, for today's class, okay? Guys, we're so close to the end. Hang in there, okay? All right. Question number 1. A boy is flying a kite and lets out 300 feet of string. So I'm going to highlight the important pieces here, right? 300 feet of string makes an angle of 30, right? Angle of 38 with the ground. That's always important if they kind of tell you where it's going to be located. Assuming that the string is straight, right? Like, because it could be like curved or whatever. How high above the ground is the kite? That's the question that they're asking, right? So they give you a side and an angle, and they're asking for another side. So it should be fairly simple to set up. So if you have your kite here, right, the string would be there. And we know that the string is 300 feet and the person is holding it here. And it makes a 38 degree with the ground, so, right? So we have our right triangle here. the 38 with the ground, right? The string makes it with the ground, so the 38 goes here. They're asking us for the height of this, of the kite, how high above the ground. So this would be, please don't forget to label. It's based on this angle here because it's the one given, opposite hypotenuse. You're going to use sine. So sine of 38 degrees is going to be opposite over hypotenuse. You put the 1 here just to see that it's a proportion, right? And so you multiply up, divide down. So 300 times sine of 38, and x is equal to 184.698. So it'd be rounding to 70 feet. This is the height of kite. Okay. Now, I can tell you, I'll add a B portion. So let's make this A, all of this. B, if the boy is 5 feet tall, what is the height of the kite, that is, right? So what if they added an element of, if this is the boy holding the string, right? And it's something like this, right? Your kite is here, right? This is the triangle we looked at earlier, right? 38 degrees. We know that the height of the boy is 5 feet. And we just figured out that the actual height of the kite is 184.70 feet. So the total is, right, we just got to add these two up. So it's 189.70 feet now, the kite, right? So be prepared for that, because, right, if it's only ever one of these, like a triangle solve, it's going to be very repetitive. So you have to watch for the curve ball there. So I'm going to do one. Question 1 is answered. So I'm going to freeze my screen here for a bit. Okay. It's asking, right? Find the angle, right? Find the angle. So this is an angle question. Okay. So it says a 25-foot ladder. So we're talking about a 25-foot ladder is leaning against the building. The base is 13.5 feet from the building, and they want the angle. So they're giving you two sides and they want the angle, right? So if this is the building here, right? Let's assume there's our building. The ladder is leaning against it like this, and it's a 25-foot ladder. And the base of the ladder is 13.5 feet from the building. It's all in feet. This is the building. And they want the angle. So let's call this A here, right? On the outside, put a question mark there. They want that angle. And obviously there's our 90 there. Let's label. This would be opposite, hypotenuse, adjacent, right? So because it's adjacent and hypotenuse, you know it's going to be right? Cosine. Cosine of A, this is an angle question, is equal to adjacent over hypotenuse. We find out what this is as a decimal. We go 13.5 divided by 25. That's 0.54. A would be cosine inverse of 0.54. And that gives you 57.32 degrees. That is the angle that the ladder makes with the ground. Okay, so I've given you two examples. One is just like the first couple of questions are all finding sides, and so 8 and 9, no secret there, is going to ask you to find an angle. So we're going to do a lot more word problems, so get ready for that. Become really comfortable with it. And then, we're basically then you're gonna be done with new stuff, except for word problems. I will make them a bit more challenging as we go along. And then we're gonna start talking about angles and angle properties a little bit more, different types of triangles, because that's also part of the curriculum. And so what your task is for today is to finish this handout, okay? And tomorrow we'll go over the questions. I'll correct them, and then you can see whether or not you got it right, okay? If you haven't done the inverse worksheet from yesterday, you can do that today. The answers are there. So you have your work cut out for you, okay? And so that's all I'm going to say for today.